Hello, beautiful chemists, and welcome to the final FRQ from the 2025 AP Chemistry exam, question number 7. This is again a short form FRQ designed to take only 7 to 8 minutes. There's 4 parts to it and 4 possible points, so you can follow along and award yourself points for things that you did correctly on your AP exam. And it primarily involves acid-base chemistry, Ka values, Kb values, and it finishes off with a quick reaction mechanism question. So get ready for a fun ride, and let's get started. Question 7 begins with a Lewis diagram, and it says, answer the following questions about the glycolate ion C2H3O3-, which acts as a base in aqueous solution. A Lewis diagram is provided, and it says, on the Lewis diagram in part A, circle the atom that accepts the proton when the glycolate ion reacts with water. Okay, so we need to circle one of the atoms, and we have to find and think about the fact that the hydrogen atom, because this is acting like a base, it's going to accept a hydrogen atom from the water. Water is going to act like the acid. It's going to want to attach itself to the most negative part of this molecule. And I see a couple of candidate places. Like, for example, here I see some electron pairs. I know that hydrogens like to attach to electron pairs. So there's that. There's a couple electron pairs here, and those are also electronegative oxygens. But over here on the end, there's an oxygen with 3 electron pairs. And it's got 3 electron pairs because presumably it's donated a proton at some point in the past, and now it wants to reaccept that proton. And because there's 3 electron pairs, this is the most negative part of this molecule, and that's why it has a negative charge. And so I'm going to circle this atom right there, which is where that hydrogen is likely to attach to. That would give us a carbon double bonded to an oxygen, single bonded to another oxygen with the hydrogen on the end. And that grouping is indicative of a carboxylic acid common in organic compounds. So hopefully you circled that right-handed oxygen. When the glycolate ion reacts with water, it forms glycolic acid, which is this. According to the following equation, the Kb expression for the reaction is provided right over here, and here's our reaction that we were just talking about, the water acting like an acid, accepting and producing OH. At 25 degrees Celsius, a 2.5 molar solution of glycolate is found to have OH concentration of 1.3 times 10 to the minus fifth moles per liter. That's that. Calculate the value of the Kb for the glycolate ion. So in order to calculate the Kb value, I need to know the values for all 3 of these. And you can do it with an ice table or without an ice table if you can think it through. And here's how I did it. Without an ice table, I thought to myself, okay, they've given me the concentration of OH, which is, I can just plug that in. I also know that because for every one of these, we get one of these, it's a 1-to-1 ratio, then the concentration of this must also be the same. If I worked out an ice table, these would both be X. And then, so I plug those in. The 2.5 moles per liter is going to go on the bottom. And if you tried to do a minus X, like 2.5 minus X, you would find that 2.5 doesn't really change much because this is really small. It's like 5 factors of 10 smaller. So this is still approximately 2.5, and it's okay to just do the approximation. So we have these two over this, and I got a Kb value of 6.8 times 10 to the minus 11. Part 2 of letter B asks, using your answer to part B, part 1, calculate the value of Ka for the glycolic acid at 25 degrees Celsius. So that's this thing over here. And we have to be aware that there is a relationship between Ka for an acid and Kb for its conjugate, or vice versa. And that relationship is that they both multiply together to get Kw in aqueous solution. So Ka times Kb equals Kw. Now I rearranged it already. So we have Ka equals Kw over Kb, and you can find this on your equation sheet on the AP exam. Kw is 1.0 times 10 to the minus 14th at 25, and Kb is what we found in part 1, and I got 1.5 times 10 to the minus 4th. Quick note about these types of questions. If you got it wrong in part 1, but used it correctly in part 2, you should get the points for part 2. So that's what they tell us in the scoring guidelines. And so if you're not confident about your answer, this is what I tell my students. If you're not confident about part 1, just be confident with it in part 2 and use it properly and see if you can't get that point. All right. Last bit of work for this exam. We are almost done with the 2025 AP Chemistry exam. And we end with a reaction mechanism. Glycolic acid can be produced from the hydrolysis of methyl glycolate. A proposed mechanism for the reaction is given. So they give us 2 steps and an overall step that's there. A student claims that H3O plus is a catalyst for that reaction. Do you agree or disagree? Justify your answer based on the mechanism given. So, I have to find out if H3O plus is a catalyst. Well, let's go find it. Up here in this system of equations, step 1, we have hydronium ion on the left as a reactant. And in step 2, we have hydronium ion over there on the right as a product. Okay, and I'm thinking back to my kinetics unit where we learned about reaction mechanisms. And there's 2 kinds of combinations here. One is if something is produced in a first step and used up in a later step, we call that a reaction intermediate. It's kind of part of something in the middle that happened. But if something gets used up in a first step and reappears later in a subsequent step and doesn't appear in the overall reaction, then it is a catalyst. And so I wrote that I agree with the student. H3O plus is consumed in an earlier step and produced in a later step. It does not appear in the overall equation, so it is a catalyst. And that constitutes one of the ways catalysis can happen. All right, well, we have just finished the 2025 AP Chemistry exam. I hope that you enjoyed my series of videos. As always, if you like them, you can hit the subscribe button. You can also send me comments or questions in the comments down below. And in the meantime, happy studying and have a great day.